this lesson, we're going to learn about compound inequalities. Before we move on to our examples, we have one vocabulary term to go over, which is compound inequality. Compound inequality is having two separate inequalities joined by either the word and or the word or. So basically what we're going to do is take what we learned already in solving simple inequalities and combining them together. In our first example, we are going to translate this verbal phrase into an inequality and we're going to graph it. Let's look at this. All real numbers that are greater than 4 or less than or equal to -1. So let's take a look at what we have. If we are looking for numbers that are greater than 4 or less than or equal to -1, it means what we're going to do is have our variable x in the center of two inequality symbols, and then we'll have the number 4 on one side and the number -1 on the other. And that's what this will look like. Here we have our x. And we're going to take this one piece at a time from the perspective of the x, where the numbers are greater than 4. So x is greater than 4. And then we're going to go back to the middle for the x, or they are less than or equal to -1. So x has to be less than or equal to -1. So x will either be greater than 4 or it will be less than or equal to -1. And this will be graphed really in the same way that we were graphing inequalities in the last lesson, but this time we'll have two on the same number line. Here we have a number 4 and a -1. And while we put these on the number line, we have to remember that even though the number 4 comes first in the expression, it actually will come second on our number line because 4 is greater than -1 and it sits here on the right. Now we have to draw our arrows. And again, just like last time, we are going to consider two things when drawing our solution set. We need to remember what kind of circle to have over each of these numbers, opened or closed, and we have to decide in which direction the arrow will go. We'll take one at a time. If x is greater than 4, then that means the number 4 will have an open circle on it, and the arrow will go to the right because that's where the numbers are greater than 4. And then x will be less than or equal to -1. Less than or equal to means we color in the circle, which indicates that the number -1 is in the solution set, and the arrow will go to the left because that's where less is. And let's take a look at the second one. The average temperature range is 45 degrees Fahrenheit to 63 degrees Fahrenheit. So again, we're going to put our variable x right here, and if x is the range is from 45 to 63, it means that x has to be less than or equal to 63, and x has to be greater than or equal to 45. And then we'll graph them. 45 will come first, and then the 63. And let's take a look. If the temperature is less than or equal to 63, that means we get a closed circle on the 63, and our solution set goes to the left. But it's also greater than or equal to 45, closed circle there. And then we color in that piece so that we have what looks like a line segment because the numbers are between greater than 45 and less than 63. So these are the two possible graphs that you will have when you're graphing your compounds and inequalities. Either what looks like a line segment in the middle, or where you have two separate arrows going in different directions. Let's look at example 2. So here we have to solve and graph the inequality. We always have to keep an eye on the variable. It will nearly always be in the center of the inequality symbols. And our goal here is going to be the same goal we've had since pre-algebra. We want to isolate the variable. So here we have to look at the y, and see that it has a negative 4 with it. And you already know that in order to get the y by itself, we have to put a positive 4. And what we would normally say is on both sides of the equation or on both sides of the inequality. Here what we have to do is put a positive 4 in each of the 3 sections. And it'll look like this. We have our 2, and we will put it with a positive 4. Our inequality symbol will stay the same. And then we have y minus 4, and we're putting a positive 4 with it, is less than. And then we have our 7, and we're putting a positive 4 with it. And we go through and we simplify. 2 plus 4 is 6. Our y is by itself. And we have a positive 11. So y is greater than or equal to 6. Y is also less than 11. And we have to remember to graph. So we start with putting our 2 numbers. We'll go right to the variable, and you could graph either one first, but you always have to read from the perspective of the y. Y is greater than or equal to 6, which means we have a closed circle on the 6, and the numbers will go to the right. Y is less than 11, so that means this will have an open circle, and the numbers will go here. So here we have one of the cases where we have a line segment that shows the solution to this inequality. Let's look at the third example. And this looks very much like what we just solved, except that there are other pieces to it. Here we have negative 13 is less than negative 3x plus 8, which is less than 11. And again, our goal is to isolate the x. And that we are going to do that by putting a negative 8 in every section of the inequality so that we can negate this constant. So we have our negative 13 here. We'll put a negative 8 with it. Negative 3x plus 8 minus 8. And then 11 and our negative 8. Then we go through and we simplify. A negative 13 and a negative 8 give us a negative 21. We have our negative 3x, which is by itself because the positive and the negative 8s cancel each other out. And that is less than positive 3. And now what we have to do is divide every section by negative 3, because right now the x is being multiplied by negative 3. So I'm going to go ahead and do that. Now as we solve this, we have to remember that because we just divided by a negative number, we have to flip both of the inequality symbols. So here we have a positive 7, but this less than will become greater than. We have our x by itself, which is greater than a negative 1. So look, we started with less than. We had to turn both to greater than, remember, because we divided by negative 3. And so now we have to graph it. We'll put our negative 1 first, then our positive 7. X will be less than 7, so this gets an open circle, and the solution set goes to the left. X is also greater than negative 1, so we keep another open circle. Solution set goes to the right, so here we have a line segment. In our last example, we are going to have, this is just a different way that an inequality can be, a compound inequality can be expressed as literally 2 separate inequalities. 4c plus 1 is less than or equal to negative 3, or 5c minus 13 is greater than 17. And so these actually are like the inequalities we just did in the last lesson. Very easy. First thing we have to do here is put a negative 1 on both sides. Now we have our 4c is less than or equal to negative 4. We'll divide both sides by the coefficient 4. And we have that c is less than or equal to negative 1. We'll do the same thing here. First thing we have to do is put a positive 13 on both sides. We have 5c is greater than 30. We divide both sides by the coefficient positive 5. And we have that c is greater than 6. And now what we're going to do is graph. We're going to represent them now on the same graph. Both solutions on the same graph. Let's work with this one. C is less than or equal to -1. Remember, less than or equal to means it's a closed circle because the -1 is included in the solution set. And your arrow will go to the left because that's where the numbers are less. And here C is greater than 6. Gets an open circle because 6 is not part of the solution. And the arrow goes to the right. So as you can see, solving compounds and inequalities is not very much different from what you've been doing so far. It's just a matter of putting the 2 into the 1.